let me start with, our topic now is industry meets the internet, and especially the subtopic, what is the subtopic? Predictive maintenance. Okay. And let me ask you, first of all, industry is a very old guy. Internet is maybe the grandparent of the industry. I think they already met each other before, so industry meet the internet is not a new topic. But what do you think, what are the new topics actually going into the condition monitoring and predictive maintenance coming with the internet technology actually? So let me start with Dr. Bredau. Can you say some words about this?
Yes, I can do this. The names condition monitoring or predictive maintenance, preventive maintenance sometimes is mixed when used in different contexts. As I started with this topic, condition monitoring, this was 10 years ago. This was driven by the focus increase availability in the plants. So this was focused on this topic, optimize the maintenance. It was experience for me. We speak with a maintenance leader of an automotive plant. He said, we work so hard to increase productivity, but we see a lot of chances to do this in maintenance, to reduce, not to increase the availability is very high, and to reduce the effort to reach this availability. So, and condition monitoring is preventive maintenance. This is the way from after break maintenance to preventive, not after times or condition based. And at this time we was focused, I said, on this maintenance topic. Now this topic comes under a complete new or under new aspects, in this with this topic digitalization. So this is then a part of this Industry 4.0, and then we see now, and then we can speak a little bit more detailed about this topic. This topic, predictive maintenance, is now relevant, caused in these new methods, and we have also no new player in this game. For instance, analytic companies, cloud companies that provided cloud, and so on. For the definition, predictive maintenance means it is not condition-based; it is a prediction, to detect weariness of components, and last but not least, the goal is that you reduce effort for high availability in the companies, and the main user are the end users of this topic.
Last night we had very good talk in the bar yesterday, also with Dr. Gallasch, and there was the topic that actually we produce so much data, and you already mentioned the topic cloud computing. And can you explain what service or what added value comes with cloud computing into the predictive maintenance? Is it only saving data, or can we do much more actually?
Now, this is a good question, because I would say this is a main question currently in the industry. What really brings, what real value brings cloud computing to industry? In a first step, my message as a software company is nothing, because cloud computing is the same what we have done for years. It is, you have anywhere a server, you save data anywhere, you can do it in your environment, you can do it in the cloud. So from a technical standpoint, there's no difference between now with cloud computing and the past. The difference is that if we have cloud computing, then we have the opportunity to plug different services together, because we have one point where all the data is or comes together, and this is accessible by everybody of the world. And really, it's accessible because it's in the internet, in the cloud. And then you can buy a service from this provider. So that means you use an app from that software vendor which analyzes your data, gives the output to another app from another software vendor which do something with this output, and so on and so on. And this is the real thinking about cloud computing. That means you plug together different services available in the world. And this also works with, I would say, in our daily environment. I don't know if somebody knows this service, if this then that, which is also a cloud solution, and you can do, if in Facebook comes up anything, then you can send this to Twitter or to my mail account or to any friend. So you can do a lot with this data available. The big question is, do we want to have all our data from our factories processed in that way? And this is why I say in the first step there's no difference, because what we need for the plants from the factories is a safe environment. The data should only be accessible by the applications and the people which are allowed to access it. And so we can use the techniques, these cloud techniques, which makes things easier sometimes. But definitely we have to think about like in the old times. So we are, and this is the big challenge in the moment, because from our private life we know everything is available. You can use the app very easily. You can have every data anywhere. And also the management and things, hey, why is it so heavy for us to implement this IT? This is because of all these security issues.
Okay, and also what we can now hear a lot is we speak, yeah, I know that you both are mechanical engineers. I'm computer scientist or computer engineer. We see that actually we have a lot of we have built a common language actually, which was not possible maybe 10, 15 years before between these disciplines. And can I ask you, what do you think, how will also the education of engineers will be changed in order to bring actually mechanical engineering? Who will be the users actually of predictive maintenance? Will be still mechanical engineers, or do we need more computer scientists?
I see prediction maintenance as a tool for people. I see prediction maintenance not so that they can replace the maintenance stuff. So, it's a tool to make this more efficient. So, and come back to what can I do all this predictive maintenance? I see the status of research not so far at the moment, that we can all predict. So, I give you an example. Festo works since years in testing of cylinder, and so on. And sometimes we have not this behavior of weariness, that we can see trends or combine symptoms, to clear faults. Sometimes you cannot predict. So, but we have more possibilities to do this. Our customer, the companies learn also at the moment. So we have one customer, give you also example, there's use from Festo welding guns in the automotive industry. So in the past we give them so strong limits. For instance, 50 million welding points is the lifetime and this maximum speed and so on. But the real behavior is in the field. The real, you can make simple diagnostic algorithm in the device, but the real behaviors in the field. And we have not the knowledge about the field. So, and now this customer connect all these devices to the cloud. This is one of our first projects. So, and we see this now as a learning process. So there are not the tools ready. That we say, combine this, when we are ready, we learn in this field. So your question was also regarding education. Come back. Mr. Gallasch said also, thinking in systems is very important, but you need also the experts. So you need the expert in data analytics. You need the expert that understand how a welding gun works. In a production, you need the maintenance. So I think you need a good mix of experts and generalists at this topic. I think for the algorithm for the university, I think there should be a lot available. But the engineers cannot use it at the moment. In the field. So this is my experience. We have companies like Microsoft or IBM. They come to us and they let us make projects. There are some analytics companies, or we have to understand their language. And this is very important in this field. And at the moment we are in this situation. And from Festo, we started the first projects in this field.
The ratio, what are the predictive and what are the unpredictable parts, where you can make some prediction for the maintenance, and where you cannot really make any prediction at all. Or a process, even process, is there a ratio?
Also, that I understand it right, where can I recommend to use prediction? And where not?
There's a ratio, how many?
No, no. I'm open to say we have not so much experience in this field. I see for a lot of mechanical parts. I said this example, cylinders and so on. It is at the moment part-wise not possible, because the behavior of the weariness is not in this kind that you see a trend. But if you have special application, when you see for this special application, for instance, for drives in a packaging machine, so then I see the same behavior, when I learn with this behavior, so then I can make a prediction for special cases. That we can say in generally make prediction for this, I see this will be more in a customized way. Prediction maintenance will be more in a customized way. You have so standard condition monitoring for your products, for exceeding of values. You can use this for troubleshooting, but to tune this for prediction, did you have to do in the field, by the customer. It's my experience.
What you are saying, prediction is a learning curve. You learn initially for any system. Prediction is fairly beginning stage.
We test our spindles or drives in a laboratory, under extremely conditions, minus 40 degree until 50 degree, so alles special mass, so but in the field is other, so it could be then instead of 10 million strokes, they works for 50 million strokes because it's other mass and so on. And this, I think, so the combination of so basic condition monitoring for the device and then this new methods from Industrie 4.0, this big data learning, this could be the ideal case for the future.
And perhaps to give something add on here, if you think about machine learning, that means that you have algorithm which learns, okay, what was the behavior in the past with this data structure, it came to that, and with that data structure it came to that output. If you have this data available, then you can nearly predict anything with a probability which you give the system, say, okay, your probability is 96%, and then it's on you to say, okay, 96% could be a lot, it's a very high probability or it's a very low probability. If you think about if you have 10,000 flights on an airport and 96% are just going right and have no accident, then it's not really good. So it depends then on the use case again. What is the quality of the data, and what quality of the output do you need? Do you really need?
What's the quality of the data processed?
Yeah.
Who is processing the data?
Well, yeah. And some things you cannot predict. If you have a wire break of a sensor, you cannot predict such things. So it's not possible.
Thank you very much.